It's time to talk about physics and the physics exam for which you just have 1 day's gap. With me is Veena Sriram, who teaches physics at the Gitanjali Senior School. What's the reason why students are so paranoid, petrified of physics?
The main reason for students being paranoid about physics is when it is numericals in math, they are able to do. But when it comes to physics, they feel it should be more of a concept-oriented subject than a numerical-oriented subject. So the quantitative part of it is what the children find difficulty in.
But why should that be so? Because that's essentially testing your understanding of the subject, isn't that?
It is, of course, testing the understanding of the subject, but then they are not able to digest the fact that they have to deal with numbers and signs. Numbers is only for math, and dealing with numbers and signs is something which is a barrier for them, and that is the reason probably they find it difficult.
So before we get into it chapter-wise, what are the most common mistakes that students end up making in the examination which you would suggest they should now avoid?
One of the most important things is in the numericals, the children forget the conversions. They know how to apply the formula, which is the formula to be applied, and substitution and simplification, of course, is very easy for them. But the main problem is they don't know how to express the answer and convert the units. This is one major problem which children face. And second thing is they are strategizing of the 15 minutes of the reading time. Children generally don't take this reading time very seriously. That is the time when they can plan on their options in the section 2, where they have 6 questions out of which they need to answer 4. This 15 minutes of strategizing will actually help them in identifying the questions which they are confident of. So I would suggest that children should be trained to use this 15 minutes of time to strategize on the choice of questions. That's
So once they have chosen which questions they will attempt, the 4 out of the 6, do you suggest that they go directly for section B first, or should they still go with section A and then section B?
It is always better to answer in the order as to how it is given in the paper. That will be easier even for the evaluator. Yeah.
Now, as far as the entire question paper is concerned, calorimetry sums, they really test the understanding of physics, whether the ice would have completely melted or not with the heat provided, and the calculating based on the understanding of the subject. Now, how can the students do better as far as the calorimetry chapters are concerned?
As far as the calorimetry chapter is concerned, the numerical is not just a single step. They need to identify the heat absorbed is in how many stages or heat released is in how many stages. So making a flow chart of this usually helps the children to identify the change of state or change in temperature, which they usually miss out on while calculating the total heat required. That is where the children find difficulty in. So my suggestion would be having a flow chart with different stages of heat absorption and heat evolution while they are practicing at home will ensure that they don't make mistakes in calorimetry numericals.
The other big chapter is the light chapter, which most students actually do well in. I mean, it's seen as a high scoring chapter. But again, the mistakes they make is that they don't know the directions in which the rays are traveling and where the images are formed. Now, how can one deal with that at the last minute? Also relating to the sign convention based numericals, some students find that confusing. Is there any kind of tips or tricks that you would want to suggest to the students how they can actually deal with this?
The sign convention, basically, if they look at their related to math and plotting of graph, and they take the optic center of the lens as the origin of the graph, then the children will not have a difficulty finding out which part of the sign convention is negative and which is positive. Because we always know the negative x moves towards the left. So from the origin, whatever measurement they do towards the left will be negative, and the ones which they do towards the right will be. So relating it to graph will help them make less mistakes.
Which are the diagrams that they need to learn for the identification or drawing?
Basically, optics, they need to learn all the diagrams, because a lot of questions on optics are based on diagrams or they ask them to draw the diagrams. So as far as optics is concerned, the main concentration should be on ray diagrams only, be it the plane surfaces or the lenses. They need to practice all the diagrams.
And when you say the diagrams, I mean, on what basis are they essentially marked? On the accuracy or even the neatness of it?
The children need to be technically correct. That is most important, the position, the size, and there are certain rules, like if we have a virtual image, we draw a dotted line. Anything that is imaginary, they represent it with a dotted line. So these concepts should be well ingrained for the children to score full on full.
Electricity, another big chapter, extensive part, lot of theory as well as numericals. How does a student prepare these chapters?
Electricity chapter is like, if we see there are, the unit on electricity has 3 chapters. So the first chapter is more numerical oriented, that is current electricity. So in that, children face problem only with the network numericals, where you have a lot of resistors connected in different patterns and they are asked for equivalent resistance. So these come only with practice. Overnight they don't get to master these numericals. So that is something which they need to do consistent practice. The second chapter under electricity is household circuiting. This chapter is a fairly more qualitative chapter than quantitative in nature. Children generally enjoy because they are able to relate it to their surroundings. So this particular chapter is a high scoring chapter as far as children are concerned. With electromagnetism, children need to concentrate on diagram based questions. Usually electromagnetism questions are all diagram based, and solving a lot of diagram based questions and applying the laws. Children need not learn the laws verbatim, but they should know how to apply it conceptually. So that is more important, and the challenge they usually face is, we have a law which talks of 3 dimensions, but they need to apply it in 2 dimension. So this is where the children find a lot of difficulty in, and solving a lot of diagram based questions will help them overcome this difficulty.
My last 2 questions. Section A is where there would always be some tricky kind of questions, especially relating to sound, at least last time with the musical instrument. There is no choice in section A. So can students expect those kind of tricky googlies in the section A?
Normally the pattern of our ICSE board is almost all the questions are application oriented. We cannot slot it as section A is only application oriented and not section B. Both the sections are equally application oriented, but generally, if, like I told you during the reading time, starting with section B will give them a more comfort level, because they have no other choice but to answer section A. So if they end up looking at some question in section A which they feel they will not be able to answer, their morale will be low. They go to section B, they pick the best of the choice, their confidence levels are high, and then they come and read the question, section A questions, they'll feel a little more comfortable.
Finally, in that 1 day, 1.5 days that they have, what should the strategy be? How should they make optimum use of their time?
They should be thorough with these single chapter units. We have heat, which has just 1 chapter, calorimetry, then sound, there is just 1 chapter, and nuclear physics has just 1 chapter. Now these 3 chapters, they have to be very, very 100% thorough, because they are high scoring. Each unit has only 1 chapter, and a day prior to the exam, it is not about opening the textbook and learning. They should have certain reading material, like they should have all the factors affecting kind of enlisted at one place, so that they are very comfortable with these factors affecting. They will be able to answer all the application based questions. They come usually on these concepts where we talk about factor affecting resistance, factor affecting pitch of sound. So actually making a note of all the factors affecting in one place, and then trying to fit it like a jigsaw puzzle with their application oriented questions will give them a feel that they know all the answers, they only need to word it in a different way.
And you don't suggest that they should look to solve 10-year board papers or any of the specimen papers that they may
That is much prior to the exam. A day before the exam, not to do that. Yeah.
What should they do on the morning of the exam? Couple of hours that they get at home.
Probably they should go through all their SI units, which are very, very important, and that is where the children make a lot of mistakes. Then the formulae, if they have a list of formulae with them, they can just go through it, and the diagrams, if they have the diagrams made as a memory map in one sheet, and they just go through it, hardly takes 15 or 20 minutes, but they have gone through all the diagrams, and that is enough for them a day. Yeah.
Lovely tips, very useful tips, great tips. I'm sure the students will be able to make good use of all the suggestions that you have given. Thank you very much for your time. Thank you.